Welcome back, welcome back. We are going to go straight into the meat and potatoes of this project, which is the data ingestion for the chess API, which we'll be performing with this Python script. But before we dig into our approach in terms of how we're going to be ingesting it, I want to be taking a look at the endpoints we'll be targeting in order to ingest the data. So as I mentioned previously, we will be targeting the player's endpoint in order to pull out historical game data for different players. So I'm just going to give you a view in terms of what that looks like. So we got our URL here, and you can see you got your player name, and it's hitting the game endpoint, and you got the date period in which those games were played. So when you flick through the game endpoints, each index underneath these games represents a separate game that was played, on which date, what moves were made, what time classification you were playing in, and who was white and black. And yeah, we're gonna do this for like a series of players. I won't be doing it for myself, but we'll be targeting all of the top players. And the way we're gonna be retrieving this data is from this leaderboards endpoint, as you can see here. And you can see at the top level of the JSON, you have all of the various chess formats that are available on chess.com. So for example, you got rapid, blitz, bullet chess, and underneath each of those formats are the players at the top of the leaderboard on chess.com. So what we're planning to do is we're planning to go through all of these chess formats, extract all the usernames from the platform, and add them onto a player name list, and we'll be using that as the basis for doing our requests. So with that in mind, we can go ahead and jump into our Python script. And we got the usual, we're pulling in our standard library in order to run the pipeline, and we're importing a couple of Google libraries in order to do cloud monitoring using the logging library. And we've got the storage library in order to interact with GCS in order to perform our ingestion. And additionally, we have various functions that we design locally to do a series of tasks on the to process the data. So it's a pretty short script. There's not really too much going on. It's very simple, and we start off by loading in this GCS ingestion settings file, which is structured in a JSON format, and this is going to be loading in our input parameters to determine how this script is going to be running. And I'll just give you a view of how that looks like here. So let's find the inputs. You can see we've got the script setting that we're deciding to run this in, the date period in which we're requesting this data, and the destination that we're landing the data in, both the GCP project and the GCP, the GCS bucket name. So once we've got that all loaded in, we start to initialize our cloud logging object. This will allow us to export our logs onto the GCP logger, where we can look through our logs on the log explorer, and we can see what are the key stages the script is encountering. We can do some troubleshooting to see are there any errors being generated while we're running the script, and this will help us during the debugging process if we're doing any developments. So that's quite handy. And yeah, once we've got everything set up, we go ahead and we request the latest leaderboard data. As I mentioned before, we will be pulling out the latest the latest top players that are currently in each chess format, and we're going to upload that into a GCS bucket. And we're also going to store the response, which we'll be processing later in a moment. The next thing we're doing here is we're listing out all of the files in our GCS bucket. So we got a bucket name called Chess API, which is storing all of our response data. And we're going to filter those files to the player directory because we want to see which players currently exist in our bucket. And for the time periods that we're trying to analyze, we want to see which responses are missing from our bucket, so we can go ahead and make those requests and fill in the blanks. So in order to do that, we have to generate our player list containing the usernames, and we generate artificially the time period that we're analyzing, which is going to be the year/month for our endpoint. And what we're doing is we are doing the cross product of those two lists in order to get player/date period, and those are going to form the basis for our endpoints in our request URL. So I'll show you what's happening in the function. So we'll dive into the functions here. So if we go to, let's see, we are going to go into, let me decide. Let's go into generate remaining endpoint combinations. So we're feeding in the objects from GCS, the top player list, and the year-month list that we generated earlier. As we mentioned before, we are doing the cross product between the two lists, top player list and year-month list, in order to get data in the following format. So you've got player name / the period of the games being played, and that is going to be the endpoint for our HTTP request. And also what we have to do in order to not repeat ourselves when we're making these request combinations is we are going to iterate through this list of all player date combinations, and we're going to check if they exist inside the GCS bucket. If they don't exist, we're going to add it into the remaining combinations list, where we will be wanting to request from the chess.com API in order to get that data, so we can later upload it into our GCS bucket. So this function will return a list of endpoints in the format espoused here, and we're going to feed it straight into this function where we are appending those endpoints onto the HTTP chess prefix. So we've got our prefix here, we're appending all of those endpoints here, and what that's going to output is a list of URLs of things that don't exist inside GCS. At which point, your script is basically almost done. The only thing left to do is to simply request all the data from that list and upload those things into GCS. So it's very simple. You're going to iterate through all of those request URLs one by one. You're going to get a games response returned, and in that process we're going to recreate that endpoint structure in GCS. So whatever you see in the HTTP request, we want to mirror that inside our GCS bucket, so it's easy to audit what we currently have. And yeah, once we get the response, as long as it's a valid response, we are going to upload that data into GCS. And that's about it. It's very straightforward. I'll give you some perspective in terms of what that looks like once you are loading in the data. So you can see here we got a chess API bucket, and we got our player endpoint, which contains all the games. We can go into one of them and we can go to a random player's name, let's say this one, and we can go into the games endpoint and we can just pick one of the dates, for example this one, and we can see, you know, this player, we got the games for December, and we can have a look at what they played at that period of time. In this case, they didn't play any game in December, so let's find a different player. Let's go backwards. And let's take this one, for example. And hopefully they have some games. I think the size of this response is a bit bigger, so we can dive into this one. And we can download it, and it looks something like this. So you can see the game they played, you know, what moves were made in that game, the time control, and yeah, we can go ahead and this will be the preparation step for us later loading in that data into BigQuery, which we'll do a bit later. But that's pretty much the end stage of the data ingestion, and yeah, all we can do is we can execute this Python script, and we can just see how that operates to give you some perspective of how it looks like from a logging perspective. So we'll just run this notebook. So we're loading in the leaderboard data to get the player names, generating the request URLs, and now we are requesting data from the chess API. Of course, we can't see what's happening from this Python script, so we're going to have to switch into our log explorer. So we'll go ahead and do that now, and let's have a look at what is occurring. So we can see you know, we are initializing our script, we're requesting leaderboard data, we are loading that leaderboard data into one of our GCS buckets, and then we are determining how many requests need to be made. So here in our case, there's 1,000 requests remaining from the combinations that we produced earlier. Although we can see we're encountering some errors with the API, so we still need to figure out some error handling for the script in order to, you know, bypass some of these bad endpoints that occur from time to time. But you know, in the past few days I've been running the script with no issues, and it's just been loading data very quickly, very rapidly. But for some reason this endpoint doesn't seem to be working. Maybe at some point in the future they'll be fixing it, but you know, we'll see. Anyway, that's all we got from a data ingestion perspective, and I'll see you guys in the next video.